while they're getting my slide up, there we go. So my name is Chenoa Tremblay. I'm a researcher with the SETI Institute, and I'm looking forward to talking to you about my work with Technosignature searches with Cosmic on the VLA. This is work it's done in collaboration with the SETI Institute, Breakthrough Listen, Berkeley SETI, and NRAO. So the question, are we alone, has been one that has pondered the human race for quite some time. Just like I'm sure we'll talk about in this conference about the evolution of stars and the evolution of galaxies, the evolution of intelligence and life potentially throughout the galaxy or universe are also important questions. And they're ones in which astronomy and astrophysics, in particular observational astronomy, have a unique position in which we can try to derive an answer. And so I'd like to talk about some of this work of how we're doing this. Now, to look for a signal that might be generated by intelligent beings somewhere else in the universe is quite a challenging problem. And it's like looking for a needle in the cosmic proverbial haystack. There are a lot of dimensions to this search space because we don't know exactly what the signal might look like, where it would come from, what its distance is, and when it might arrive. But to answer this question is still an important one to do. It's important to still delve into the unknown and answer this. But with so much search space available to us, how do we try to go about processing this information? Our answer to this problem is Cosmic, the Commensal open source multimode interferometric cluster on the VLA. Now, the VLA, the Karl G. Jansky Very Large Array, is a 27-element interferometer in New Mexico. Tony has already made reference to this telescope so far in the meeting. Each of these 27 antennas are movable into 4 different primary configurations, from the dense compact D array to the long baselines of the A array. And also there's a wide variety of observational bandwidths that are available to us. Cosmic is a new digital backend at the VLA, stationed in the west chamber where the old correlator used to be. For each of the 27 online antennas, we receive a copy of the signals that come off from the digitizers. So one copy goes on and happily gets processed through WIDAR, just through standard observations based off from a PI's request. The other copy goes into the Cosmic's digital system, which is the middle picture here. This digital system is receiving data at a rate of over 2 terabytes per second. So we are dividing up that signal using demultiplexers, ingesting the signal, channelizing it to 1 megahertz coarse channels, and then putting it through a standard set of processing through either a calibration pipeline or a search SETI pipeline for technosignatures. In addition to this digital processing rack, we have 16 GPUs online, 2 petabytes of external storage, and some more equipment that we'll be putting in place soon. In order to build Cosmic, it has taken a very large team of people around the world. We have our team members are in South Africa, the UK, the France, and the United States. And all of us together have put a tremendous amount of contribution in order to get this project working. The targets for this project are typically stars. We know that now that most likely if you want to build an intelligent civilization, you need low mass or intermediate mass stars to have that longer timeline in which they can develop, in which planetary life has a potential for existing. So our main targets are a 30 million star catalog that was put together based off from the Gaia star catalog. The paper I reference here is for a 1 million star catalog, and a 30 million one is in process. We also have what we call the catalog exotica. There's a number of other sources that may have been of potential interest to the SETI community, and those are also in our catalog as well. So Cosmic is a commensal system. It's completely agnostic as to whatever the field of view that the primary observer is requesting to look at. It doesn't matter on the frequency. The system runs in real time and has very little human interaction at this stage. But what it does is inside of a particular field of view of whatever the telescope is looking at, it's forming between 5 and 31 coherent beams towards these targets of interest, as well as forming an incoherent sum across the entire field of view. So this allows us to get that sensitivity and primary information from those targets, but also fill in all of the space in between. Even if we lose the spatial information, it still allows us to look for some of the brightest signals in the sky. So the Cosmic Search is running in a real time on a pipeline. And although there's a lot of communications, radio communication in particular here on Earth that entails a wide range of signal styles, what we're primarily looking for is a signal that would be 6 hertz or less in bandwidth, relatively continuous, and preferably something that drifts in time and frequency, like is seen here. So Voyager is one of those samples that we often use as something that's the furthest man-made object or human-made object that is also sending out these technological signals. And our real-time pipeline, what you can see in the plot here is that our real-time pipeline did find a signature of Voyager, and then you can see what that signal looks like. And this was all put into a press release that if you scan the QR code, you can see. One of the benefits of having Cosmic on the VLA is associating with the VLA's All-Sky Survey. This is a survey that covers all of the declination above -40, and it's in the third epoch of its observation, which started in January. And as of February, Cosmic has started recording along with this sky survey to make the most comprehensive technosignature search so far to date, covering so much of the sky. So currently we are observing along with VLASS. We are also observing across all frequencies during all calibrations to make sure that every observing frequency that is available to us through Cosmic is fully operational and calibratable. We are deploying the last 6 of the servers, which would give us 40 computational nodes, 1 GPU server for development and 1 GPU server for post-processing, as well as our storage. Our software pipeline is in the final stages of science commissioning, and everything is looking really good so far. So where are we heading? So this is a plot that shows you where most of the technosignature searches to date kind of sit as far as the number of objects in a form of transmitter rate versus like the minimal detectable power in the equivalent isotropic radio power plot. VLASS, with our observations along with VLASS with Cosmic, covers a fairly wide range due to the distance squared relationship of the power. But anywhere between 1 parsec and 2,500 parsecs is where our objects are covered as far as distance space. And then if we add in all of the standard PI science, we hope to reach the limits that are in the blue box and the green box for Cosmic for the coherent and incoherent beams as we go forward. Although Cosmic is a very exciting project and one that I have had a lot of involvement, it is not the only SETI project out here. And it's an increasing number of telescopes that we've been able to use in order to look for these signs of extraterrestrial intelligence. I've named a few here, or listed a few in particular, that are SKA precursors and pathfinders in which we have experiments. But I've been building an increasing list through time allocation committees, target of opportunities proposals, and NAPA proposals in Australia to continue with these types of styles to cover wider ranges of frequency bands and a wider range of telescope types in order to look for these signals. In particular, I want to earmark 2 experiments here. One is on the Allen Telescope Array, which is a 42-dish interferometer. 23 of those dishes now have brand new broadband feeds, the Antonio feeds. The dishes cover 300-meter baselines, and it has a new revamped digital signal processing system and is undergoing science commissioning. If you want to learn more about this telescope, it's you can check out Wales poster. I think it's poster 17, if I understand correctly. The next one is the Breakthrough Listen experiment, which is kind of a sister experiment to COSMIC, but on the Meerkat telescope. Here, instead of receiving the signals after the digitizers, it's after calibration, but it is also following through as an automated Commensal SETI program on this telescope. And it's agnostic, again, to the observing frequency, where the location of being looked towards, as well as the subarrays being used. And there's an poster online of Daniel's that describes the system in more detail. Now, SETI with the SK would allow us, whether we detect something with COSMIC or on the Meerkat system, to still probe deeper into a wider range of communication styles than we are capable of doing with the current generation of telescopes at much further distance and with greater sensitivity. And so this paper by Andrew Simeon talks about how this could be accomplished from an SK perspective. And in another paper by Cherry-Ung explains the SETI with the ngVLA. And the major benefit for this is a difference is not only the observational frequencies that are available, but also the larger baselines for the ability to localize a signal to a greater degree. So if you want to know more about COSMIC or our efforts with SETI, there was a press release this morning that explains where we're at with the COSMIC project and why we're so excited about it. And there's also a webpage on the NRO science site where you can also learn more about how COSMIC interfaces with the VLA. We're also looking for collaborative opportunities. As part of science commissioning, we've looked at masers, pulsars, we've done some imaging, we've been in discussions with the Real Fast group on the VLA for doing fast radio bursts and some axion dark matter work. And we have the potential for future science, and we would love to hear from you if that is of interest. Thank you very much, and I'm happy to take any questions.
All right, so any online? Nope. Oh, there's one. Christina.
Very nice talk. I was just wondering, since COSMIC was an add-on commensal system to the VLA, not part of the original design, what were some of the challenges that your team encountered with the development and the commissioning, and what could we learn from this for ngVLA and SKA?
Excellent question. So some of the challenges is the data rate coming in. And so not only that, what some of the specifications, Tony alluded to some of the technology is getting a little bit older and things like that. So things like the waveforms are a little bit more broader than we would ideally like for some of the signals coming in. So to get all of the antennas online, we've had to consider some of those challenges as well. So that's one of the biggest challenges. As far as going forward, we're hoping that our troubleshooting and our development of these high-speed Ethernet backends, it fits into a much smaller space than some of the older systems have, and we can input these almost 3 terabytes per second data rates. And so hopefully that can be a learning point for future development for these new generation of telescopes.
Right there.
Thanks, Joe Cunningham, Astron and Leiden. Awesome stuff, Chenoa. You've just got an amazing data set there for astrophysical phenomena as well. I was just wondering if any of your team are thinking about exploiting this for radio stellar studies or even exoplanet studies as well, or are you just making the data public for anyone to play around with? Because the time frequency information you get is really quite phenomenal for this type of studies.
Yeah, so right now, I mean, as a commensal system, we have to be very careful that we're not competing with the primary observer. And so we definitely have that in our minds. What we'd like to do is in the future is to be able to make this a little bit more available as even a shared risk, where you could run your observations alongside with your WIDAR, with your known proven setup, but also maybe get some additional information through COSMIC at either a higher time or higher frequency resolution that that could add value to the data set that you already have. So we do hope to make that available after we finish learning what we know about the system.
Cool, thanks.
There's one over here.
Oh, whatever. Oh, go ahead, Doug.
Thanks for the nice talk. Doug Johnstone from NRC Hertzberg. What do you expect, or what are you finding as your false positive rate? And are you overwhelmed by them, or have you tuned it such that you're not getting many false positives at all? I'm just curious.
Yeah, so right now we're still kind of collecting almost everything and learning a lot more about what is the nature of the environment. You know, standard VLA operations isn't going to run at 6 Hertz frequency resolution. So we're going to pick up some RFI that wouldn't have been picked up with standard observations and things. So right now we're collecting all of that information into a database and understanding and learning that environment and starting to build, you know, rules into that pipeline in which we can, like, we know that it's not going to look like this. That's RFI, and we're going to do this. So we're still working on that. I can tell you that something like a galactic center observation for about 2 hours produced 5.5 million hits, but that's hits. That's not filtered in any sort of way. And so we're still learning that system and that filtering process at the moment.
Probably have time for one more question. Oh, here we go.
Hi, so this was a very interesting talk. I was just wondering, so it's great to see that there's still new things being produced for the VLA, but how are you affected then by a probable transition period to ngVLA? Are there already plans how you will be transferred to the new instrument?
I think that depends on kind of how the plans, like it was talked about earlier, as far as you know, what are the transition plans for the VLA itself? It is connected solely with the VLA at the moment. I don't know exactly what the plans are for future of putting something similar on ngVLA. I'm sure there are discussions being had.
All right, thank you. Let's thank Chenoa again.